Whenever you book a flight, you're tapping into a system whose core logic was actually forged decades ago. Today, we're going to look past the slick website and dive into the foundational code that has been powering global airlines for generations. It's a fascinating story, so let's get into how it all works.
I mean, just think about that question for a second. How do you program an entire airline? Back in the jet age of the 1960s and 70s, this wasn't just a fun thought experiment. Airlines were hit with this absolute tidal wave of data, and they desperately needed a way to manage everything, not just seats on a plane, but the whole complex dance of logistics, crews, and machinery.
So here's our flight plan. First, we'll dig into the incredible complexity airlines were up against. Then we'll look at the special programming language they used to solve it. After that, we'll see how they brought all that logic online in real time, which was a huge leap. And finally, we'll explore why so much of this decades-old code is, believe it or not, still flying high today.
All right, so to really get why the solution was so brilliant, you first have to understand just how huge the problem was. Programming an airline wasn't about selling a few tickets. No, it was about orchestrating this massive, global, moving machine.
Seriously, think about what it takes for just one flight to get off the ground. You have to track maintenance logs for every single part on that plane. You have to schedule pilots and flight attendants based on super complex union rules and mandatory rest periods. Then you've got loyalty programs with millions of members. And don't even get me started on the pricing. Calculating fares with all the taxes and rules is a nightmare. This was way beyond what normal programming could handle at the time.
So, faced with this totally unique challenge, the industry didn't go for the scientific or academic languages of the day. Nope, they turned to something built from the ground up specifically for business problems.
And here it is. Meet COBOL, the Common Business-Oriented Language. I mean, the name really says it all, doesn't it? It was created for exactly the kind of data processing and file management that big businesses, and especially airlines, were drowning in.
And this is the absolute key takeaway. COBOL wasn't built for, calculating rocket trajectories. It was built for complex rules. It was a master at handling logic like, if a passenger is flying internationally, and they're in business class, and they have elite status, then you apply this specific baggage allowance. That right there, that's the native language of an airline.
What's so cool about COBOL is that its syntax was designed to look a lot like plain English. This meant that business managers, the people who actually knew the rules, could literally read the code and confirm it was correct. It built this amazing bridge between the business side and the tech side, and it quickly became the go-to language for encoding all those unbelievably complex workflows.
Okay, so having all that airline logic written down in COBOL was a huge step. But that's only half the battle. How do you make that logic instantly available to thousands of gate agents and travel agents all around the globe? Well, that needed another piece of revolutionary tech.
This is where CICS comes in, the Customer Information Control System. You can think of CICS as the system's great connector, or maybe it's traffic cop. It took all those COBOL programs and turned them into these neat little transactional services. That meant a user at a terminal could make a request, CICS would handle it, and get a response all without bringing the entire mainframe to its knees. It was the essential bridge between the code and the user.
Before CICS, everything was done in these slow, clunky batches. You'd feed the computer a stack of punch cards, and maybe the next morning, you'd get a printout of the flight manifest. It was totally non-interactive. There was just no way to ask, hey, is seat 14A available right now?
CICS just blew that old world away. All of a sudden, you could have a real-time conversation with the mainframe. A travel agent could ping the system, book a seat, and get an instant confirmation. The airline's central database went from being a dead archive to a living, breathing thing.
And the scale was just mind-boggling for the time. We're talking about systems that could handle thousands of people using it at the exact same time, all booking flights, checking schedules, and updating passenger info. This was really the birth of the real-time, large-scale enterprise we know today. Now, when you put these two technologies together, COBOL and CICS, airlines could build something incredible. They started layering their own custom logic on top of it all. Systems that would automatically ground a plane for maintenance or perfectly balance crew schedules with union rules. The code stopped being just a set of instructions. It became a living rulebook that actively ran the entire airline's operations. Which, amazingly, brings us to today. And here's the part that might surprise you. A lot of that exact code, written in COBOL, managed by CICS, is still running the world's biggest airlines. So, why on earth hasn't anyone replaced it? Well, it's the classic double-edged sword. On one hand, these systems are rocks. They are incredibly stable and have been battle-tested over decades. They're woven into the very fabric of how an airline works. But on the other hand, that deep integration makes them terrifyingly hard to change. It's a massive, massive challenge for any kind of modernization effort.
So for most airlines, the answer hasn't been to rip everything out and start over. That's just too risky. Instead, they adapt. They keep that core COBOL logic, the engine that's been running reliably for 40 years, but they wrap it in modern APIs. It's kind of like a translator. So that slick mobile app you're using, it's probably talking to a program written back in 1975.
And that really leaves us with a huge, fascinating question to think about. Is all this old technology the solid, reliable bedrock that makes modern global travel possible and safe? Or is it a fundamental bottleneck, holding the entire industry back from true innovation? As we've seen, the real answer is probably a little bit of both.